Hello and welcome to this session. This is Professor Farhat. In this session, we will discuss data normalization. Now, this topic is designed specifically for CPA candidate, specifically CPA candidate who are taking the Information Systems and Control exam. In this session, I would lay the ground about what is data normalization. So what is data normalization? Well, it's a fundamental process. It's an important process in database design. So when you design the database, you have to structure it, organize it in a way according to certain rules. Why? Because this will help protect the database against what we call anomalies and ensure logical data storage. Simply put, you're organizing the database better, connecting the data the right way. This is basically the purpose of data normalization. We're going to be doing so eventually using mathematical rules such as the first normal form, the second normal form, the third, starting with the first, but we'll discuss those in a separate recording. The key of this recording is just to kind of tell you what is data normalization and why we need it. That's basically the purpose of this. And once we looked at the mathematical rules or the first normal form, second, so on and so forth, we're going to see, for example, the second normal forms build on the first one, the third build on the second and the first, so on and so forth. So as the need for the organization change, if the data is normalized, it's easier to modify and expand without extensive restructuring. And that's the whole purpose of data normalization. Eventually, the companies will scale. And if that's the case, if we're organizing the data properly, then it's more adaptable to the evolving data requirement of application and user demand. So it's going to be easier to build it, easier for the users to manage it, to pull queries, to pull report from the data. So the first thing we're going to do is we're going to look at the benefits of data normalization. So what's going to happen is we're going to see what problem or what problems we are trying to avoid. So we're going to lay the foundation. We're going to present the problem before the solution. So we're going to say, well, here's a problem, and this is how data normalization will solve this problem. We will not go into the first normal form, the second, third, until the next recording. The first, I want to show you what's the problem and how data normalization would help. Then we'll go into specific solution. So let's go ahead and get started. Before we proceed any further, I have a public announcement about my company, farhatlectures.com. Farhat Accounting Lectures is a supplemental educational tool that's going to help you with your CPA exam preparation as well as your accounting courses. My CPA material is aligned with your CPA review course such as Becker, Roger, Wiley, Gleam, Miles. My accounting courses are aligned with your accounting courses broken down by chapter and topics. My resources consist of lectures, multiple choice questions, true-false questions, as well as exercises. Go ahead, start your free trial today. So what are the benefits of data normalization? What are the benefits? Well, to avoid data redundancy, to improve data integrity, to reduce update anomalies, to simplify queries, to enhance securities, among many other benefits. But this is good enough. If we have those 5 benefits, they're good enough to see the need for data normalization. So if data normalization can help with these 5, you're going to see why data normalization is important. So what I'm going to do is this. I'm going to take each benefit, starting with to avoid data redundancy. I'm going to explain what this is, show you an example, then show you how the data normalization would help solve a problem with data redundancy, to avoid redundancy. And we'll go through each one of those to kind of explain the benefit, present the problem, present the solution. Without going into the first normal form, second normal form, we'll do that in a separate recording. The first problem is to avoid redundancy. Normalization helps eliminate duplicate data. Redundancy means the same data again and again. Now, redundancy is good in cybersecurity. Redundancy is good in internal control, but it's not good in data. So we don't want data redundancies in data. So this redundancy not only wastes storage space, because that's what happened, it could also lead to inconsistencies within the database. So to make sure that each piece of information is stored only once, normalization reduces the overall disk space and simplify the data management. So this is one of the benefits. For example, in a sales database, customer information like address, phone number, emails, so on and so forth, might be repeated in every sales record if not normalized. This leads to unnecessary duplication of the same information. So what's going to happen? We're going to introduce normalization that will separate customer information into different tables with a unique customer ID linking sales to customer. What does this all mean? Let me show you an example, but I want you to use your imagination. I'm gonna assume that you are familiar, or you are not familiar, know a little bit about database, what a database would look like, a field, a row, a column, so on and so forth. So this is unnormalized table. So this is the what I'm going to call in quote a problem or an issue. So we have an order ID 001, Elise, her address 123 Maple Street, Anytown. The product ID PO1, the product is widget name. Product ID 002, Bob's address, product ID 02, gadget. Product number 3, Elise again, 123 Maple Street, Anytown, PO3, and she bought a gizmo. So what's the problem in this example? There's more than one problem. We're going to focus on one. We're going to see there's more problems. Well, notice here, Elise, her record is twice. So let's assume Elise updated her record. What we have to do, updated her record means, let's assume for the sake of simplicity, she updated her address. She moved. Then what we have to do, we have to go into each row and update the address. So what happened if we updated the address here and we did not update the address here? So that's the problem. So the problem is redundancy is evident as customer detail like Elise's name and address are repeated. What if she changed her name too? You know, if she has a last name and she got married or she got a divorce, are repeated for each order. So this repetition can lead first to access storage and inconsistencies in updating customer information across multiple entries. So how would data normalization would help? Here's what's going to happen. We're going to separate customer information into a distinct table linked by a unique customer ID to reduce duplication. So what's going to happen? We're going to have a table called customer table. And this customer table would only include customer data like Elise and Bob and John and so on and so forth. So we'll have their customer ID, and we're going to call this something else, a key to this table, and their addresses, their email, whatever we want to collect about them, date of birth, when did they start as a customer, so on and so forth. Okay? And so this will solve this problem. So notice here what happened is to avoid redundancy, we created another table doing data through data normalization. So it will help avoid redundancy. Now order table, we have order ID. Now rather than writing Elise's name, Elise is customer 01, it's link. So in case we change her address or her name, it has to be changed only once and everything is good. Everything will follow. So this is to avoid redundancy. Also, data normalization would help us improve data integrity. So by removing redundancy and minimizing dependency anomalies, normalization improves the integrity of the database. So integrity constraints are easier to enforce in a normalized database because changes to data in one place reflect throughout the entire database. Basically, it's an extension of what we talked about, reducing the chances of creating data inconsistencies. For example, in a university database, if the course name is stored in both enrollment and courses in both of these tables, and the course name changes, and course name changes all the time. Not all the time, but they do change. There might be inconsistencies if all instances are not updated. So as we just mentioned, the problem with Elise's address, this is helping not only reducing redundancies, it's also improving data integrity. So normalization ensures that the course name is stored only once and referenced elsewhere throughout foreign keys. And I'm assuming here you know what a foreign key versus a primary key is. And we'll talk about this when we look at the second normal form, in the next few lessons. So here let's take a look at an unnormalized table. The enrollment ID is E001, student ID S01, course ID C01, introduction to computer science. Again, enrollment, student ID, course ID, introduction to computer science. Now what happens if we change introduction to computer science to introduction to, call it now C++ or C or some other name, just computer science? Then what's going to happen is we want to make sure the the name is updated in every issue. So to resolve this problem, we're going to create courses table, and each course will be connected to a course ID. So CO1 is Introduction to Computer Science. Now, if we change Introduction to Computer Science to Introduction to C++ or C, or Introduction to Java, we just be more specific, or just simply Computer Science, then that's it. Then when we reference this course, we have to reference CO1, and whatever we updated here, it will be updated in the new table. And this way we have the integrity maintained. So the course name is dependent solely on the course ID, but is redundantly stored in the enrollment table, redundantly. So this setup can lead to inconsistencies if the course name changes and not all the entries are updated. Kind of the same thing as, in a sense, redundancies and integrity, they go hand in hand. So by isolating courses in a separate table and linking them via course ID, any update to the course name need only be made in one place, enhancing data integrity and simplifying management. So that will solve the problem. Again, I'm showing you what are some issues and what can be done. We'll formalize all of this later on when we look at the first normal form in database management, so on and so forth, first, second, third. We could also reduce update anomalies. In an unnormalized database, modification like updates, deletion, and insertion can lead to anomalies. For example, if data is duplicated and an update is made to one instance of that data but not to others, it creates inconsistencies. Well, again, I know I am like beating a dead horse at this point, but it's good to kind of see this. Normalization arranges data in tables and columns with defined relationship that ensure that updates are propagated uniformly. Example, in a staff database, if an employee's department is stored in every project record they work on, changing the department name requires update to multiple records. With normalization, the department data would stored once, would have a department name, and any update would automatically be reflected across the database. So let's take a look at this example. Here we have an unnormalized table, employee ID, employee name, department, and project. Employee ID EO1, Elise, engineering, working on project Alpha. EO2, Bob, sales, working on Beta. EO1, Elise, engineering, working on project Gamma. What we do, so the problem here is department information is stored with each project record. So these are the project record. Now, if a department designation changes, or if an employee moves to another department, then we have to update multiple records, increasing the risk of errors. So what do? Well, we create separate tables for employees and their department to make sure that department information is stored once and referenced elsewhere. So now we have an employee ID. For example, Elise is an employee. We have employee ID EO1, Elise, and the department. Now, we don't mention what department. The department is linked to the department table. We create a department table, engineering. Now here what we have a project ID, project 01. EO1 is what? Elise and the department, and the project is Alpha. So Elise would encompass everything, her name, her department. If she changed department, it will be reflected in this EO1, because if her department name change, or if she changed department, everything is reflected in EO1. This minimizes the need for multiple updates and reduce anomalies. To simplify queries, what are queries? Queries are when you query something, when you go and you search for something. Having a normalized table, it will simplify queries. So normalized data is structured in such a way that SQL queries can be more straightforward and efficient. And this leads to improved database performance and response time. So we can get the information faster and get the information that exactly we are looking for. So complex queries can become simpler because the data is structured logically, reducing the need for repetitive joins and extensive computation logic. So it's much easier to look up information. So consider a non-normalized table. As I told you, I'm going to show you first the problem. It's easy to see the problem, then kind of see the benefit of normalizing the database. So consider a non-normalized table where employee data, including department details, is mixed with project data. Complex join and data filtering are needed to extract simple lists such as all employees in a department, because now you have to take a look at project and department at the same time because they're mixed up. Normalization separates employees and department into distinct tables, making such queries more straightforward and efficient. So it just makes looking up stuff way easier. Okay, let's take a look at this example. We have library ID, LO1, book title, War and Peace, so we have a book title, the author, genre, member ID, and member name. Now we have basically a library ID, the book title, it's checked out by Elise, War and Peace, the author, the member ID, which is Elise, M01, and Elise. Now, what's the problem here? Mixing book and member information complicate queries. For example, generating a list of books borrowed by a member involves filtering throughout the column, not directly through the relevant query. So we're gonna have to go through columns to figure out, if we're looking for a list of books borrowed by a particular member. So what do we do then? Well, by segregating books and members into separate tables and using a loan table, this loan table will manage borrowing. Queries become more straightforward and focused, improving performance and clarity. So here's what we do. We have the book, we have a book table, and for example, War and Peace, the author, and the genre. Separate this into the book table. And we have an ID, B01, B02, we have many books, title, author, genre, whatever we want to put, ISBN number, whatever we want to put, we can add to this, whatever we want to add about the book. Then we have a member table. Member table, M01, Elise, member name. We could have first name, last name, address, whatever we want to do, but it's a separate table. Then we have a loan table. Loan table, L01, B01. This is the book, B01. Now we know B01 is War and Peace. So this is it. The book is B01, so it's easy to know everything about this book. Anything changes to this book, we just have to change B01, this record here. And the member ID that took this book out is M01, Elise. Elise could change her name, move, whatever we want to do, make changes, change her email or phone number. We can change it in one place, and it's easy to update everywhere. And if we look up a member and which book they borrowed, the list is much easier. Enhancing security. Data normalization will enhance security. With data normalization, it becomes easier to implement security measures at different levels of the database. And I hope with this data security, you would see the benefit. For example, access controls, and we talked about access control a lot in information system and control exam, can be applied more effectively when sensitive data is isolated in a specific table. So sometimes there are certain data in a table that you want to keep isolated. You don't want everyone to have access to. Only privileged users you want to have access to. For example, what could be? If sensitive employee salary data is stored along the general employee detail in a single table, well, anyone can access this employee data, will see the salary. So controlling access to just salary detail is difficult without exposing all employee data. So normalization allows separating salary from the table, from the employee table, securing this data, securing the salary data. The best way is to look at an example. Let's take a look at this example. We have employee, this is unnormalized table, employee 01, Elise, salary 100,000, department HR. Now, what's the problem here? Sensitive data as salary is mixed with general employee information, complicating effort to restrict access to sensitive data without limiting access to less sensitive data. Maybe you want to look up Elise's phone number or email or address, and we don't want you to be able to look up the salary. So what do? We're going to separate. We're going to have two tables, employee table, where it's going to include an employee ID, unique ID, E01, that's fine, the name, the department. Remember, we have a department ID and we have another table for, it's right here, another table for the department, because Elise could change department, the department, they could change their name as well, linked to a department. Then we have a salary table. Salary table, E01, but that's related to Elise. Now, for this salary table, we can restrict access to this part of the database. We can restrict access to this part of the database. Therefore, when we look up E01, if you don't have privileges to go into this database and look at the data, you cannot see the salary. And this is what we mean by restricting data. Isolating sensitive salary details in separate tables allow for more granular security controls. And this is what we want. We want to be able to give access only to the right people, authorized personnel only, while other employee information remain more broadly accessible. So what we did is we looked at few problems, and we saw how data normalization would solve the problem. So this is an introduction. The next thing, we're going to go into the details. First NF, second NF, so on and so forth, to see how it gets done, like mechanically. Let's take a look at this multiple choice questions from farhatlectures.com. An online retailer is reviewing their customer and order management system to address issue of data inconsistencies and redundancies. So we have data inconsistencies. It means it's updated in one place, not the other, and redundancies. It's the same information in multiple places. What is the primary benefit of normalizing their database to eliminate duplicate customer record? So what's the benefit of removing data inconsistencies and redundancies? Is it reducing the number of customer complaint? Believe it or not, you might be able to reduce the number of customer complaint. I'll tell you why. Because if the customer updated their address in one place and you kept using the address from another place where it's the wrong address, they could complain. But that's not the main reason why. What's the primary benefit? But it could help. Because think about it, the customer go into the system and updated their address, but their address only updated in one place and not across the system because the data is not normalized. But that's not it's a good answer. I would say this is not a bad answer, but let's see if there are better answers. B, reducing data storage requirement and improving data consistency. I would say B is better than A. I'm not saying A is wrong. It might reduce the number of customer complaint, but B is a better answer than A. So I can eliminate A, keep B, and move on to C. Increasing the speed of the internet connection. No, it does not increase the speed of the internet connection. It could increase the speed of the data, your database, how you query data, increase the speed of the database management. Yes, but it's still, even if the answer increased the speed, reducing storage requirement and improving data consistency is better, but not internet connection. So that's an easy elimination. Enhancing the graphical user interface of their web application. Yeah, it's good to have a better user interface, but removing data inconsistencies and redundancies doesn't increase graphical user interface on the web application. So as I suggested, or as we guessed, the answer is B. What should you do now? You want to go to Farhat Lectures, look at additional MCQs, resources that's going to help you if you're studying for the Information Systems and Control exam. Invest in yourself. Farhat Lectures is always here to help, and stay safe.